Today we've got a great project built in vanilla JavaScript, coming right up. Hi, I'm Mark Lassoff. Welcome to the channel. Thank you so much for clicking on this video. Today, we're going to build an entire project in HTML, CSS, and JavaScript. This is a great project if you've learned the fundamentals of JavaScript and are looking to fit the pieces together into something that actually does something useful. Our project is a weather forecast app. It'll give you the weather forecast for the next 7 days. It's a pretty cool application. I think you're going to enjoy it. And it's pretty easy to understand how it works, even if you're fairly new to JavaScript. Now, if you like this kind of video, do me a favor. Hit that like button and subscribe to the channel. We come out with new educational videos for people who are becoming web and mobile developers a couple of times a week. All right, with that, let's take a look at the app and see how it works. All right, so you can see on the right-hand side of my screen here, we've got the weather forecast app. If I click refresh, notice we get this warning. You wouldn't get this on mobile, but the file wants to know your location. That's just a warning before the geolocation is accessed. Once it is, in a moment, the weather forecast for the area where I am will be displayed. What's happening behind the scenes is that the latitude and longitude of the user is being obtained. Once it's obtained, that information is being passed to the OpenWeather API. The OpenWeather API is providing the information for the forecast in a format known as JSON. And then our program goes ahead and parses the JSON to display the information as you see it here. I didn't spend a lot of time on the look and feel of this. I just wanted to get it working because the mechanics are the most important part of this. So with that in mind, let's take a look at the code itself and go through it line by line so you have an idea of how it works. So of course, line 1 is called our document type definition, and that simply declares that we're writing HTML5 code. On line 2, we have our opening HTML tag, and then on line 4, the head section of our document. As you probably know, all HTML documents are divided into 2 sections, the head and the body. The head section contains meta information and links to code. Meta information is essentially information about your application, and the links can be to external code that you might use during your app. We've got all of those here, so let's take a look. So first off, we have our meta information. We have the character set that we're using, which is UTF-8. We have what's called an XUA compatible meta tag for old Internet Explorer browsers. Probably don't really need that one anymore. And then we have our viewport meta tag on line 7. The viewport meta tag simply declares that our viewport is going to be the width of the device, and the initial scale is going to be 1.0 or 100%. We're not going to magnify or minify the content. We're going to display it at 100% magnification by default. Then we have 3 link tags. These link tags come from Google, and they let us use the Google Fonts API. We're simply using the Google Fonts API to download a font called Bitter, which is the font that I used to render this, at a weight of 500. All of these links are going to external websites. You can see the first one going to fonts.googleapis.com, the second going to fonts.gstatic.com, and then finally fonts.googleapis CSS2, and there you can see the rest of it, family bitter, weight 500, and that's simply describing the actual typeface that we're going to be using from the Google APIs. If you haven't used Google Fonts before, you can just go to fonts.google.com. There's I think over 1,000 fonts available to you there, and they're all pretty cool. So after the link to our Google Fonts, we then have our style sheet. This is CSS code starting on line 13, and it defines the look and feel of our application. So let's go through the CSS while looking at the application itself so we can see how the CSS is impacting the actual look of the app. So first we have our body. And this body selector is designed to style everything in the app. Since we want everything to use the Bitter font, we styled the body with font family Bitter Serif. And of course, that Bitter font coming from the Google APIs. The Weather Day class, which begins with a dot on line 17, styles all of the individual boxes that have the forecast for each day in the application itself. So first, we create a 1-pixel solid gray border around our Weather Day class, and you can see the box for Thursday, Friday, Saturday, etc. all have that border. The border radius of 10 is what gives us the rounded corners. Padding of 10 pixels gives us some space between the edge of the box and the content. The margin at the bottom is giving us the space between the boxes, so we have a little margin space. You can see our background color is blanched almond. And then the box shadow is what's creating the drop shadow for each box. The first 4 values for box shadow simply declare where the box shadow is and its offset, and then we declare the color. Ours is just a 34% gray. You can see RGB 000 is black, and 34% is the opacity. The images that you can see in each box are floated to the right, and that's how we get the little image for each weather day on the right-hand side of the box. And then we style the individual paragraphs. Each of the pieces of information is in an individual paragraph, so I reduced the margins from the default style sheet from 16 pixels to 5 pixels. So that's why there's not a lot of space between the sunrise and sunset line and high temperature and low temperature, etc. Finally, I styled the H2 and H3 used for the day of the week and the weather description. You can see Thursday and a few clouds. And again, I reduced the space between each of those items by setting the margin top to 5 pixels and the margin bottom to 5 pixels. Otherwise, everything is from the default style sheet, but the styles I use here are fairly simple, and they give us the result that you can see on the right-hand side. So now that we've looked at the head section of our document, which contained our meta information, the connections to other scripts, and our styles, we're going to look at the body. The body contains the HTML and the actual JavaScript. You're probably going to be surprised that there's not much HTML here. Almost everything is generated dynamically. Let's take a look. And there you can see our body starts on line 43, and we've got essentially 2 HTML elements in the body. The first is the H1 header that says weather forecast, and then we have a logical division called forecast on line 45. That ID forecast will be populated dynamically once we get the weather information from the API. So the balance of the code is dedicated to our JavaScript, and this is what is getting the information from the API and displaying the information on the screen. We also have to make a couple of conversions here in order for the information to be readable by humans. So you notice line 47 is an actual function called getPosition. In here, we're setting up to get the actual position and parse it. I'm going to scroll down to the bottom of our code. Notice we have all of these functions, and then at the bottom we have this line on line 134. Navigator.geolocation.getCurrentPosition getPosition. This command uses the geolocation library in the browser to run the getCurrentPosition function. When the position is available, it calls getPosition as a callback function. Because we don't know how long this operation is going to take, we don't know how long it's going to take to obtain the position from the browser, we have a callback function. Only when the position is available does that callback function getPosition run. This is an asynchronous operation. In fact, a lot of our application is dependent on asynchronous operations. This built-in function has the asynchronous operation built in. It knows not to call the callback function until the information is available. So on line 47 starts the callback function, and notice it has position passed into it as POS. From POS, using the chords object, we can get the latitude and longitude. I go ahead and create local variables called lat and long, and then I pass those to getForecast. So all that this getPosition function does is once the position is obtained by the geolocation API, it breaks out the latitude and longitude and passes it to the getForecast function. The getForecast function takes the latitude and longitude and it creates this URL. Let's look at the entire URL. So you'll notice here that the URL goes to api.openweathermap.org. That's the API that we're using. It's a great API because they have a free tier that gives you quite a lot. You can get your own account at openweathermap.org, and you can use the API just by signing up. So before you build this application yourself, you're going to need to do exactly that, because you're going to need your own API code. The code that you see here in my URL is not going to be working anymore, and frankly, I don't want you using it. So you'll go ahead to this website and obtain your own API code, and you get that through signing up. Very easy. So there's openweathermap.org, and notice then in the query string, I'm passing latitude, longitude, and this latitude and longitude is filled in from the geolocation API. We're excluding current, minutely, and hourly. I didn't want the current conditions, the minutely forecast, which is a minute-by-minute forecast, or the hourly forecast. I simply wanted the daily forecast for this app. And then at the end, you can see API ID equals this long hash of letters and numbers. That's my API code. And that's what you're going to have to get individually from openweathermap.org and fill in your own code. So you're just going to replace this here with your own code that you obtain. That's how you'll be identified for your API calls. So if we look at the code here in the program, you can see the let_UR equals, and then we're building the URL with everything that I showed you before. But then when we get to latitude, notice I'm inserting the latitude that was passed into the function, and I'm inserting the longitude that was passed into the function, again from the geolocation API. So we're going to get the forecast for the exact location for the latitude and longitude that were provided by our geolocation. I then pass that URL to getWeatherText. GetWeatherText is an interesting function. It may look different than other functions you've seen before. This function is an example of the async await concept in JavaScript, designed specifically for asynchronous functions. Functions where you might have, for example, a race condition if you don't run them asynchronously, where the next line of code is going to execute before the function's done processing. Here, we're going to have to get the weather from the API. Well, we don't know how long that's going to take. So we've got to run this asynchronously and wait for the data to come back before the subsequent lines of code are executed. So notice this function is identified as async function getWeatherText URL. Then we have letWeatherObject await fetch URL. So fetch URL is going to the OpenWeatherMap URL with our latitude and longitude, and it's awaiting a response before it assigns that result to weatherObject. Now, I want to show you exactly what comes back here from the URL, because we'll get the weatherObject from fetch, and then we're going to take the text from weatherObject.text, and we're going to convert that into something that humans can read. So at this point, let's go ahead and hit a console log, and we're going to console log out weather text. You know, I'll console log out weatherObject too, just so you can see what that's producing. You also notice, by the way, I gave my variables very, very obvious names so you can see exactly what they are from context. It's a good habit to get into. All right, so let's open our developers tools. This way we'll be able to see the results here in our console. And let's refresh the program. And we'll see the results of those two console logs. So there we go. So there is the weatherObject. Now this has all of the response data, for example, the HTTP headers and the status text. So this has a little more information than we need. What the .text command does on line 62 is it extracts the text. And here you can see all of the JSON that has come back in a single block of text. That has to be parsed before we can do anything with it, because right now it's in text format. We need that to be an object that our browser can actually parse. So notice that we send it to parse weather, and the parse weather function runs json.parse on line 69. That's what gives us the parsed object. So what I'm going to do is I'm going to add one more console log here so you can see once the object has been parsed what it looks like in the browser DOM, the browser's memory. So then it's called weather.json because then it's a true JSON object. All right, so let's go ahead and refresh, and then we got to wait for it to do its thing here. This is exactly why we need asynchronous functions. All right, so there you can see, first of all, the return object, the text, and then the converted JSON object. The converted JSON object has useful information in here, and we can dig into it and actually see the information for the days in our forecast. That's where all the information comes from. So all of this is now stored in weather.json. You might have noticed there was a sub-object in the JSON called daily. That's where the daily forecasts were, and that's where all the information we're interested in is. So the next line of code takes the information from the daily inputs and stores that in a separate variable. So that's happening on line 71. Daily forecast equals weatherjson.daily. Now, because we have nodes for each day in the forecast, we've got to loop through them and extract the information. So that's what our loop on line 73 does. We're looping from 0 to the forecast length. Then we're taking a day at a time with daily forecast x and figuring out what the date is, or day of the week, for that particular day. Let's take a look again at the console. So if we look inside our object here, here's daily. Here are the daily forecasts. We're looping through first 0, then 1, 2, 3, etc. And we're getting our information out of there. Now, the days are just labeled 0, 1, 2, 3, 4, 5, 6, 7. But we want to label them to our user Thursday, Friday, Saturday, Sunday. The code immediately inside our loop is dealing with that. We get the day from the day forecast x. So that's getting either the 0, 1, 2, 3 node and storing that in day. So day, the first time through, will store all this information in node 0. Then we're trying to figure out, okay, what day of the week is node 0? So the today variable creates a new date object, gets the day, and adds x. Remember that our days are labeled 0 through 7. So today we're starting on Thursday. So Thursday is 0, Friday is 1, Saturday is 2. Why we're adding to the day is to get the day of the week based on Sunday being 0, Monday being 1, etc. So that's all we're doing on lines 75 through 78. If today is greater than 6, we're subtracting 7 to start at Sunday. That'll give us the appropriate day of the week on line 79. We call the function getDayOfTheWeek, and we pass it the 0 through 7 value. So let's look at the getDayOfTheWeek function. And there you can see, it simply returns an actual day name based on the value. So if it's 0, it's Sunday. If it's 2, it's Tuesday. So that's how we get our day of the week, because the date object doesn't have that. It just looks at days. 0 is Sunday, 1 is Monday, etc. So we store our day of the week in the variable day of the week. Then we get the description, which you can see in the output as clear sky or overcast clouds. We get that, notice, by going to day, weather, sub-0, description. And you can see it's right there. I'll pull that out a little bit for you. So weather, description, clear sky. So that's where we're getting that from in our application. We then get the icon right here. The icon has a code, 01D, that references or represents the icons that you see. We'll use that later to display the icon. You can see the sunrise and the sunset. We get the high temperature and low temperature. We get the high temperature and low temperature from this temperature node. Now, these numbers may look a little crazy to you. This particular API by default uses the Kelvin scale for temperatures. So we have to convert that to something human beings know, like Fahrenheit. So you can see we actually use this function on line 84 and 85, K to F, Kelvin to Fahrenheit, and we use the number from the API and we convert it to a Fahrenheit number. Here's the K to F function, which first figures out the Celsius temperature, which you get by subtracting 273 from the Kelvin temperature, which is passed in, and then we convert to Fahrenheit. Now, if you're in a country that uses Celsius, you can, of course, eliminate that step if you'd like, and simply display the temperatures as Celsius. We then get the humidity from the humidity node. We get the wind speed and the wind gust from the wind speed and wind gust nodes. We then take all this information and we're passing it to a function called displayWeatherDay. DisplayWeatherDay gets the day of the week, the description, the icon, the sunrise, sunset, high temp, low temp, humidity, wind speed, and wind gust. DisplayWeatherDay simply takes all of the information we've gotten from the API and it marks it up with our HTML in order to display what you see on the right-hand side of the screen. So we create a logical division in a variable called out using JavaScript on line 94. Notice that's got the image source tag in there first. and we put in the icon code, which came from the API. Now, by the way, if you're wondering where the whole URL came from, well, I read the documentation for the API, which is a step a lot of people skip, but one I highly recommend if you want to really learn how to use the APIs that you're working with. We then put in the day of the week in an H2, the description in an H3, the sunrise, sunset, high temperature, humidity, etc. The only conversion I'm making here is I'm rounding off the wind speed and the wind gust to display it in whole numbers. But that's what gives us our HTML. I then use document getElementById forecast.inner HTML, and I append the out variable. So remember, this is getting called for each of the nodes in the JSON. There's a Thursday node, which is 0, a Friday node, which is 1, a Saturday node, which is 2, and it's creating the HTML dynamically. It's then displaying it inside our logical division called forecast. If you don't remember, our logical division called forecast is on line 45. And we simply insert each of these a day at a time. They're styled by the existing CSS. All right, so that just about does it for our application. Those are all of the major functions that make the application run. We went over the HTML, the CSS, and finally the JavaScript. If you enjoy this video, don't forget to hit that like button and subscribe. That's how YouTube knows that this is a video it should be recommending to other people. Also, I'd recommend that you use the Open Weather Map API for your own projects. It's a great API. It's got a lot of great elements to it, including weather maps that you can include in your projects. All right, so thanks again for watching. I'm Mark Lassoff. Thanks for watching the Framework channel here on YouTube. Bye-bye.